So I have a specific technique or step-by-step procedure for determining the empirical formula from a percent composition. It's easier to show you this step-by-step procedure on the board. So here we go. First step is to assume a 100-gram sample. We do this just to make the math really easy. If you go back to the problem that we were going to work, we had 24.7% potassium, 34.76% manganese, and 40.50% oxygen. If you have 100 grams and you have 24.7% potassium, it's easy to see that that would just be 24.7 grams of potassium. I did the same thing for manganese and for oxygen. Now once I have the mass of each element, I can use my periodic table to determine how many moles that represents, just by dividing by the atomic weight. So for potassium, that's going to be 39.10. And for manganese, 54.94. And for oxygen, 16.00. Now I just plug all of these into the calculator and I can calculate how many moles. Now notice that I wrote down a whole lot of decimal places there. This is one of the more critical places to keep all of the numbers and not round them off too soon. The reason is, if you have a ratio of 7 to 15 versus a ratio of 1 to 2, you're going to get a very similar fraction. So in order to get the correct answer for some of these, you really need to keep all of those digits. You don't have to write them all down on your paper if you don't want to, but you need to have them in your calculator. I'm going to do the same thing for the other two. Okay, now think about what we're trying to find here. We're trying to find the empirical formula. And a formula looks at the number of atoms of each element in the compound. So our empirical formula should look something like K, M, N, O, but we don't know how many of each of these we have. We just know the mass ratio of those three elements. So what we're trying to do is come up with the atomic ratio for each one of those. And since you always have the same number of atoms in a mole, the molar ratio will work. So we could stop right here and we could put K 0.631714, Mn 0.63269, and O 2.53125. And that would represent a formula for this compound, and it would have the correct ratio of moles. However, we haven't ever seen a formula that looks like this. Why? Because this should also represent the number of atoms, and you can't have 0.631714 atoms. So we need to take this ratio that we have and turn it into a whole number ratio. So that's what we're going to be trying to do now. There's a little math trick involved here. So step 1, assume 100 grams. Step 2, calculate moles. Step 3 is going to be divide by the smallest number of moles. So step 3, divide by smallest moles. This is a math trick that makes sure that at least one of those numbers becomes a whole number, because one of them is going to become 1. Okay, if I divide this number by 0.631714, which is the smallest, I'm going to get 1 potassium. I'm going to divide this number by 0.631714. To not change the ratio, I have to divide all of them by the same number. Okay, when I plug this into my calculator, I get 1.00155. Plugging that one in, I get 4.00696. So the question is, how close do I have to be to a whole number to round it off and call it good? And the answer is you have to be within 0.05. So if you were anywhere between 0.95 and 1.05, you're close enough to round it to 1. If you had 0.93, it's not close enough. So what do you do if it's not close enough? If it's not close enough, then you have to keep going. And you would have to multiply all three of those numbers by something until you end up with 3 whole numbers. And when you do your homework, you're going to get some more practice with this, so that you can practice doing one that's like that. For us, these are all close enough, so now we're going to round them. So instead of having this ridiculous formula that's right there, we're now going to have KMnO4, which is potassium manganate. All right, there you go.